Alright, welcome. So Unit 4, Day 3 notes, absolute value inequalities. This lesson is going to be a combination of the first two lessons in this unit. So remember when we solved absolute value equations, we had to split the original problem into two equations and solve. So today's lesson is going to be very, very similar to that. We're going to do the same thing when we solve absolute value inequalities. Absolute value inequalities just turn into a compound inequality with an and or problem. So here are some things that you have to know about absolute value inequalities. When we have something like the absolute value of x is less than a, and this applies to the less than symbol and the less than or equal to symbol, we use the and rule. So how you remember this is you think less than. And remember, with and, the solution is where the two individual inequalities overlap. So basically the intersection between the two inequalities. Now for this one over here, the absolute value of x is greater than a. So if we have the greater than sign or the greater than or equal to sign, it's an or problem. So we can think greater. And or means everything. The solution is everything the two individual inequalities touch. All right, so here are some steps to solve absolute value inequalities. Like I said before, it's very similar to when we solved absolute value equations. So step one, we isolate the absolute value expression on one side of the inequality. So if the absolute value expression is not by itself, we got to move stuff to the other side of the inequality symbol. Step two, we are going to determine if you have an and or problem. So remember, less than and greater. So if it's a greater than or equal to, it's an or. And if it's a less than or equal to, it's an and. And then for step three, this is step 3, this is step 4, and this is step 5. So step 3, we're going to create two inequalities. So equation 1, we're going to drop the absolute value bars and then solve. And then for equation 2, we drop the absolute value bars, change the sign of one side of the inequality, and then flip the inequality symbol. All right, so there are 3 steps that you have to do for that second equation. All right, so moving on to step 4, of course, we're going to solve, and then step 5, you're going to graph your solution and write in interval notation. So number 1, we have the absolute value of 2x plus 1 greater than 5. So since we have a greater than symbol, it's an or problem, right? We have to think greater. So looking at number 1, the absolute value expression is on its own, so I don't need to move anything else. So let's go ahead and create our two inequalities. So I'll have 2x plus 1 is greater than 5, or, because it's an or problem, 2x plus 1, and then that 5 is going to become a negative 5, and then we need to flip the symbol. So that greater than sign becomes a less than sign for this inequality. So for this one over here, all I did was drop the absolute value bars. And then for this one over here, I dropped the absolute value bars, changed the symbol, and flipped the sign. All right? And then we're going to go ahead and proceed to solving this inequality. So the first one in blue, I'm going to go ahead and subtract both sides by 1. I have 2x is greater than 4. And I'm going to divide both sides by 2. So x has to be greater than 2. The second one, I'll subtract both sides by 1. I have 2x is less than negative 6. And then I'll divide both sides by 2. So x is less than negative 3. All right, so here we go. We're going to graph these two inequalities. Remember, I'm going to graph above the number line, and then the solution will be on the actual number line itself. So we have x is greater than 2. But first of all, let's go ahead and write negative 3 and 2 down here. So looking at x is greater than 2, it's a greater than symbol. We're going to have an open dot, and we're going to shade to the right. For x is less than -3, we have an open dot above -3, and we're going to shade to the left. And since we have an OR problem, it's talking about everything. So what are all the x values involved? So to graph the solution, we have an open dot at -3, and then we're going to shade to the left. And then for 2, open dot, we're going to go ahead and shade to the right. So the interval notation, we read from left to right. We are going to start from -infinity, comma, -3. So since this is a -infinity, we put a parentheses there. And since this is a -3 with an open dot, we give it a parentheses there. But we can't forget about this side over here. So since we have two intervals, we need to separate these things with the union symbol. And then we proceed. So we start at 2, and then it goes towards positive infinity. So we give this a parentheses at 2, and then a parentheses at infinity. That is the interval for number 1. So number 2, we have the absolute value of x minus 7, which is less than 5. So since this is a less than symbol, that means we're dealing with an AND problem. And we can see that the absolute value expression is on its own, so I don't need to move anything to the other side. So let's go ahead and proceed to writing our two inequalities. So for the first inequality, we're going to drop the absolute value bars and just keep everything else the same. So x minus 7 is less than 5, and we have x minus 7. I just dropped the absolute value bars, and then that less than symbol that we had originally is going to become a greater than for this inequality. So x minus 7 is greater than -5. So remember, we look at this and then we change the sign, right, for this other inequality. And then we're going to go ahead and solve. So I'll add both sides by 7. So x is less than 12. And then for this other one, we'll add both sides by 7. So x is greater than 2. So our main characters are 2 and 12. So looking at x is less than 12, that's an open dot, and we're shading to the left. Whereas x is greater than 2, that's an open dot, and we're shading to the right. And don't forget, we have an AND situation, so we're looking at where these two inequalities overlap, or where they intersect. Looking at these two inequalities, they intersect right here. So let's go ahead and graph our solution. We have an open dot at 2, and we have an open dot at 12, and we're going to shade between 2 and 12. So the interval notation is from 2 to 12, where 2 gets a parentheses because it's not included, whereas 12, it gets a parentheses because it's not included too. So from 2 to 12 is the interval. Number 3, we have 4 times the absolute value of x plus 3 is greater than or equal to 8. Notice that the absolute value expression is not on its own. It's being multiplied by 4. So to get rid of that 4, we need to divide both sides by 4. And we get the absolute value of x plus 3 is greater than or equal to 2. And then since the absolute value expression is on its own, I can go ahead and determine if it's an AND or problem. So we have it greater than or equal to. We're dealing with an OR problem. So think greater. I'll write my two inequalities. I'll write x plus 3 is greater than or equal to 2. And then for the other one, it's x plus 3 And since we have that greater than or equal to before, this inequality is going to get a less than or equal to symbol. And then that 2 is now going to become a negative 2. All right? So looking at the blue inequality, I'll subtract both sides by 3, and I get x is greater than or equal to negative 1. And for this other inequality, I'll subtract both sides by 3, and I get x is less than or equal to negative 5. So we're going to go ahead and graph our inequalities. Our main characters are negative 5 and negative 1. So notice that I'm writing the negative 5 first before the negative 1 because we have to think of this as a number line. The negative 5 is less than negative 1, so that negative 5 is going to appear to the left more than the negative 1, right? So this is where the number line is negative, and this is where the number line is positive, right? So here we go. We have x is less than or equal to negative 5. That's a closed dot, and we're going to be shading to the left. Whereas x is greater than or equal to negative 1. That's a closed dot, and we're shading to the right. So remember, we're dealing with an OR problem. We're looking at what are all the x values involved in number 3. We can see that the negative 5 is included, and it's going towards negative infinity. So closed dot, we're going to negative infinity. Whereas at x is negative 1, it's a closed dot, and we're shading to the right, going towards positive infinity. So closed dot, shading to the right, and this is our solution. We have two intervals. So looking at this part, we are starting at negative infinity, and then we're ending at negative 5. So we'll have a regular parentheses at negative infinity, and since negative 5 is included, that gets a square bracket. But we can't forget about this part here, and since we're dealing with an OR problem, we have to write union. So we start at negative 1, and we're going towards positive infinity. So negative 1 is included, so that gets a square bracket. And positive infinity gets a regular parentheses. So this is the interval notation for 3. Number 4, we have the absolute value of 4x plus 16 is greater than 8. Notice that the absolute value expression is not on its own, so we'll subtract both sides by 16. So we have absolute value of 4x is greater than negative 8. And then this is where we decide if it's greater or less than. So is this an and or problem? We have a greater than symbol there, so it's greater. Therefore, it's an or problem. And then we'll go ahead and write our two inequalities. So 4x is greater than negative 8, and 4x is less than positive 8. So this greater than symbol becomes a less than symbol. And for this negative 8 here, this becomes a positive 8. All right, so let's go ahead and solve. Let's divide both sides by 4, and I get x is greater than negative 2. And for this inequality, I'll divide both sides by 4, and we get x is less than 2. So the main characters are negative 2 and 2. So looking at x is greater than negative 2, it's an open dot, and we're shading to the right. Whereas x is less than 2, it's an open dot, shading to the left. So since we have an OR problem, we're looking at all of the x values involved. So if I look at x is greater than negative 2, which is this guy right here, we're starting at negative 2. It's not included right now, but as I shade to the right, I'm going to approach x's positive 2. And since I am going to touch positive 2, that open dot now becomes a shaded dot, so that 2 is included. And then we'll proceed to positive infinity. Okay? Likewise, if I look at x is less than 2, so at 2, which was originally an open dot, now a closed dot because of this, right? We're going to go ahead and shade to the left, and as I approach x is negative 2, this open dot is going to become a closed dot because it's going to get touched by this inequality. And then we'll proceed to negative infinity. So it looks like all of the x values are included, so I'll shade everything. This means that we have an all real numbers situation. All right? So the interval notation is from negative infinity to positive infinity, and they get regular parentheses. Number 5, we have the absolute value of 3x plus 5, which is less than or equal to 14. So we know that the absolute value expression is not on its own because of that plus 5. So I need to subtract both sides by 5, and I get the absolute value of 3x is less than or equal to 9. Now, because we have the absolute value expression on its own, we can determine if it's an and or problem. We have a less than or equal to symbol, so less than, therefore it's an and problem. And then I'm going to write my two inequalities, so 3x is less than or equal to 9, and 3x is greater than or equal to negative 9. I'll divide both sides by 3, so I have x is less than or equal to 3 here. And then for this inequality, I'll divide both sides by 3, so x is greater than or equal to negative 3. So our main characters are negative 3 and 3. So x is less than or equal to 3. It's a closed dot, and we're shading to the left, whereas x is greater than or equal to negative 3. It's a closed dot, and we're going to shade it to the right. And remember, we're dealing with an and problem. So where do these two inequalities overlap? Where do they intersect? Well, they intersect here. So that is our solution. So at negative 3, it's a closed dot, and at positive 3, it's a closed dot, and the solution is between negative 3 and 3, but negative 3 and 3 are included because both of them have a closed dot. So writing our interval notation, negative 3 to 3, they both get a square bracket. Alright, so number 6, we have the absolute value of 3x minus 9 all over 2 is less than or equal to 12. So, since the absolute value expression is being divided by 2, we need to multiply both sides by 2. So the two 2's cancel, and I'm left with the absolute value of 3x minus 9 is less than or equal to 24. So the absolute value expression is on its own now. We can determine if it's an and or problem. We have less than or equal to. So this is a less than problem. So it's an and less than situation. And then I'll write my two inequalities. I have 3x minus 9 is less than or equal to 24. And 3x minus 9 is greater than or equal to negative 24. I'll add both sides by 9 here, so I have 3x is less than or equal to 33, and then I'll divide both sides by 3, so I have x is less than or equal to 11, whereas over here I'll add both sides by 9, and I'm left with 3x is greater than or equal to negative 15. I'll divide both sides by 3, so x is greater than or equal to negative 5. So the main characters are negative 5 and 11. Looking at x is less than or equal to 11, it's a closed dot, and we're shading to the left. And for x is greater than or equal to -5, it's a closed dot, and we're shading to the right. And remember, we're dealing with an and problem, so where do these two inequalities intersect? It intersects right here in the middle. All right? So, at -5, it's a closed dot, and at 11, it's also a closed dot, and then I'm going to shade like so. So the interval is from -5 to 11, and since these two values are included, they both get a square bracket.